My name is Markus. I'm a research scientist with the group, and I work a lot on metrics. So what I'm going to show here is just part of the process of how we build models that help highlight different features within urban environments. So, we all kind of know, we all kind of hear this buzzword. What is a 15-minute city? What are those features of a city or those characteristics that make a 15-minute walkable city? And really, the aspect that this research is talking about is access to amenities and services. So in a 15-minute walkable city, one can walk to all their daily needs that they need every day. So I'm going to highlight some of the research we're doing around building these kinds of models to help understand and predict the necessary amenities and services required in a city to achieve this. So what this really is about developing urban performance metrics from observable data. And a lot of what we do is around understanding what these complex functions are. This is the KPI that we're trying to address. In this case, it's access to amenities and services. We use a complex process to kind of understand that environment. And then we use that information to help us make decisions around what kinds of proposals we should be making in a certain context. So we develop these models around what those contexts are. Some people call these representative twins or digital twins. I hate that word. And the characteristics that we're really trying to look at are amenities and services. And then the decisions we're trying to make are around where to locate those in a new context. And we do this by training these models on large amounts of data. And this data is gathered from various sources. And I'll highlight some of the data sources that we're using right now to kind of do this to help us as we understand an intervention. So an intervention could be, what if I add 50 homes to an area? What are those amenities and services I'll need in that area to ensure that I will sustain a 15-minute walkable distance, or I'll be able to provide, 15-minute walkable city and all of those metrics that go along with it. So I'm going to start with kind of some of the case studies, some of the research projects that are ongoing in the group right now. And the first one I'm going to talk about is East Palo Alto. So we're working in an area which is basically a food desert, a retail desert. It is an isolated community that is becoming kind of pushed out by kind of what's happening to the east and west of it. So East Palo Alto is right here in the middle. To the north of it, you have the new Meta headquarters. To the south of it, you have the Googleplex. So this is some of the highest per capita earning area, or one of the highest per capita earning area in the whole country. And East Palo Alto is kind of a working class neighborhood that's nestled between them. And we are looking at what a large parcel that's being developed in that area by an impact investor who has the agenda of saying, what should I be building here to ensure that this community can sustain itself in the future? And this work is really focusing on one aspect of it, which is the amenities and services that need to be included. So what we started to do, this is kind of the area, this is kind of a blow up, it's called the Ravenswood District. Right now, what we started to do is we started to look at, well, where are commuters going today? So what you see here is a list of all of the census block destinations, the top, I think this is the top 15 census block destinations, and the cumulative miles incurred for non-work and non-school related trips from East Palo Alto to destinations. Currently, this community is very dependent on auto-centric mobility to for all of their daily needs. And what that leads to is about 70,000 miles in 3 months for 50,000 people. And these are the census blocks that are most visited. You've got trip counts, the number of trip counts on the x-axis, and the miles traveled. So Santa Clara gets, the highest amount of trip counts, as well as contributes the most mileage. So whatever amenities and services that people are going to in those locations are probably the most important for us to look at. So we looked at the top 15 census tracts to investigate this. So when we started to look at these distances, we started to look at where all these areas were on a map. And we started to make an argument to the state around how much CO2 is being contributed to the, as California's overall CO2 profile. And it turns out that because of lack of amenities and services in East Palo Alto, there's about 28 metric tons of CO2 per 3 months, per quarter, is being contributed because of a lack of amenities and services. So this was a very strong argument to change zoning regulations in a community that is currently not, does not have a lot of amenities and services in the area. So this is kind of what these analyses look like. We were looking at where people were traveling to for eating and highlighting the census blocks that were most traveled to. We were looking at where people were going for shopping, and you can see kind of the gradation, the darkest red being the least, the lighter red being the most. This is actually incorrect, sorry about that. And so on and so forth for different trip purposes, recreation, same thing. And then we started to look at what are the POIs that are located in those areas. So we can start developing a profile of what the amenities and services were needed by the community of East Palo Alto for daily needs. Now, I'm going to quickly switch over to a different line of research because it gets more granular in this analysis. So basically what we said was if we could envision a world where we have live-work symmetry or more walkable communities, we could reduce carbon emissions by almost 75% in East Palo Alto. And, of course, on the right-hand side, you can see the dream image of what that could look like for everybody, which was a segue into the image scope, but we're going to talk, we did a little bit reverse, but we'll talk about that in a minute. Okay, so this analysis now is going into another level of research where we're looking at the most walkable communities in the United States. So if we want to build kind of a model around what are those amenities and services that have developed over time in communities that have this kind of characteristic of high walk scores, how would we extract that information? So what we're doing is we started to do some research to understand what ratings, what are the most walkable cities in North America? And it turns out that San Francisco usually scores within the top 3. So we started with San Francisco and we said, this is kind of the overall rating of walkable cities in North America. New York, surprisingly, wasn't number 1. I would have thought New York would have been number 2, but it turns out that San Francisco beat it. Boston is number 3. Who knew? So when we started to do this, we started to look at what the most walkable neighborhoods were. And we're using kind of 3 data sources to do this research. We're using traditional census data to understand the demographic profiles of residents of different census blocks. We're using replica data, which is mobility data, which is extracted mostly from telecom data, from your phones, from people's phones. And we're using SafeGraph data, which provides us with all the statistical information about the various points of interest in a location. SafeGraph data is basically extracted from the same data that the IRS uses to understand what are all the commercial operations in a certain area, where SafeGraph is generated from IRS data. So really what we try to do is we try to extract the amenities and services found in walkable communities and then extract the demographic profiles of those patrons using each one of those establishments. And our kind of analysis architecture looks like this, where we're using mobility data to understand where people are going and at what time of the day and who. And we're using POI interest, point of interest, SafeGraph data, to understand the characteristics of those establishments being visited. And our initial analysis starts with something like this. We were looking at replica data to understand what parts of the city are most walked. So the very green, the very top, means the least amount of car trips per day. Most trips are by biking or by walking. So those areas for residential origin points, so people are leaving their home, not driving. People who live in those areas. So then we were looking at where are they going. So these are the most frequented destination groups. As you can see, they're very close to the areas where people are going. So with that information, we started to look at what are the trip purposes that people are using for these two clusters, these two neighborhoods, which were the darkest green, or the most walkable areas on the area. So we started to generate kind of what were the trip purposes that most of these residents were doing. And then we overlaid that with kind of the larger context area. Most of this is walkable, which is why we did that. And we understood that there were 60,000 trips for non-automobile trips that were not work, not social, or not school related for Q1 of 2023. And we overlaid that with the point of interest data. So what you see here is a sample of kind of what that information looks like for all the points of interest that we go to. So these are what the institution's kind of top categories are. This is what the trip purpose was in replica. This is what the top category of the institutions are from SafeGraph data. And then these were the trip counts and the distribution of the trip counts for the overall population. And then with that, we're able to overlay these two maps, and this is the work and research that's happening now, so that we can actually extract all the granular information about what those destinations actually are. And that's the work ongoing. The point of this, though, is that really what we're trying to understand is what are the most needed amenities and services needed in a walkable community. And that is purely quantitative at this point of our research. The next line of research, which is what we're going to run these experiments on, will be to understand what we get from some of these generative models, which are not as, this is all statistical information, not probabilistic, which is what we're going to talk about in the next series of talks.